All right, I want to talk about section 8.15, unknown measures of similar figures. Now, this is going to be kind of similar to the similar figures and the congruent figures that we've been working on. But the idea or the basics is this. If we start with a problem that says Shelby's father wants a swimming pool. Now, doesn't have enough money to buy a full Olympic size swimming pool. An Olympic size swimming pool is 50 meters long and 25 meters wide. He can only build a pool that is his pool is 25 meters long, but it's a similar shape. That means if we were to draw these two, and the question, of course, is his pool is 25 millimeters long, and the question would be how wide is it? Well, if I drew an Olympic swimming pool right here, I could see that it is 50 meters long and 25 meters wide. And if Shelby's father's pool is a similar shape, then I know it's just going to be the same thing but smaller. And what I do know is it's 25 meters long. So the question is, first I need to find that scale factor that we've been doing. And I can see that these two sides are similar. So the question is, what do I multiply 50 by to get to 25? Well, I multiply it by 1/2. Or 0.5, either way, doesn't really matter. So if I want the width here, I'm going to do the same thing with this number, and I'm going to do 25 times 1/2, or, excuse me, 25 divided by 2, which is 12.5, or 12.5. And that is how I can figure out similar figures based on using this scale factor. And the scale factor is going to continue to become important as we are learning. Okay, let's look at another quick example. Say we have these two shapes. Larger rectangle, smaller rectangle, very similar to the one we just had. And this is 8, 6, 8, 6, 3, 4, 3, and x. And the question is, first, what's the scale factor? And then, what can we figure this out without using the knowledge that we know about rectangles? Because I'd be tempted to just say, well, because this is a rectangle, look, I know it's going to be 4. But let's test that and make sure that it is true, in fact. So if I look for my scale factor here, my question is, well, what am I multiply 8 by to get 4? Well, in this case, it's again times 1/2. And I can check and see 8 times 1/2, right? 1/2 of 8 is going to be 4. And the same is also true on this side. 1/2 of 6 is 3. So I can do the same thing down here, and I can indeed get that 4. Now, I didn't like that example as much as the previous one, so sorry if it didn't really help. Let's take a look at a triangle. We'll call this example 2. Oops. Turns out I'm terrible at drawing triangles, and I don't know why. Must have missed that part in school. God, I can't even get it to match up. Here's our triangle. These triangles are indeed similar, even though they may not look it based on my artistic abilities. But take it for my word. And the question is, what is the measure of x? Well, I need to figure out my proportions and my ratios here. And what I can do is I can build a similar set of ratios just like I was doing before. A long time ago I was comparing ratios. I can say that the ratio between these two sides is the same as the ratio between these two sides. So I can say 4 is to 6, and remember I can write it like that, as 5 is to x. And once I have it set up like this, I can solve it all sorts of ways. The easiest way, of course, is using that butterfly method or that cross multiplication. And I can just set it up as 4x equals 6 times 5, or 4x equals 30. Divide both sides by 4, and I have x equals 30 divided by 4 is 8.5 maybe? Let me check. 30 divided by 4, 7.5, darn. But you can see how I was able to figure out this missing side based on just using some cross multiplication. Another way that I could do it is I could find out the ratio first. So I could say, okay, 4 times, what do I multiply 4 by to get 6? Well, I would multiply 4 by 1.5, right? Times 1.5. And I bet if I multiply 5 times 1.5, I will also get to my answer as well. And let me, I'll just do that on my calculator up here. 5 times 1.5, 5 times 1.5 is indeed 7.5. It better be, otherwise I did something terribly wrong. Because once we get to this geometry, you'll often find that there's a lot of different ways to do things and to get to the right answer. There's one more that I want to show you, and it's relative to how it kind of asks some of the questions a little bit weird. This is one of the questions that they say, number 5. And it says, use the scale factor to create a new ratio. And it looks like this. 1/3 scale factor of 4. And I think these are a little bit unclear, so I want to say how I would do these. I would treat it as this is like a little bit of a ratio, just like I did in the previous problem. So I'd say one side of 3 is equal to the other side of, or one side of 1 is equal to the other side of 3, and then I would just have a multiplication set up that would be equal to a similar triangle. Actually, let me check the answer key real quick, and I'm a little bit curious what they put for this one. I think it's not the best worded problem I've seen, and that's kind of saying a lot considering some of these problems in this book are a little bit weird. Number 5 is going to be 4/3. 4. So how they do it in the book is 1/3 scale factor of 4 is all they do is just multiply it together. So we'll go with that instead. So I'm just going to do 1/3 multiplied by 4, which is my scale factor in this case. And that does kind of make sense a little bit. Say if I had like a square and this side was 1/3 and I had a larger square that was a scale factor of 4, I would get 1/3 times 4 to get this value of my length right here. So this answer would of course be 1/3 times 4 over 1, which is 4/3 for my answer. And that's how you'll do those numbers. And that number of odd ones are 5, 6, and 7. Aside from that, you should be able to figure everything out. If you are confused, please ask for help, and I'll be coming around and seeing how you're doing. Good luck.